Hey, AP Stats class, I want to go through a few of these problems from today's class. Uh, First off, we have this problem about the 2016 Summer Olympics. The United States and China won the most medals. Suppose we randomly select a medal from the 191 that are represented in the two-way table. Notice across the top we have gold, silver, and bronze medals. And then vertically here we have United States and Canada, and then of course the total on the bottom and the total on the right as well. Suppose we randomly select a medal from the 191 that are represented in the 2A table. Define events. G is a gold medal. U is the United States. And B is bronze medal. Part A here. Find the probability of a bronze medal given that the athlete is from the United States. So A, we are trying to find the probability of randomly selecting an athlete who won a bronze medal out of all the medalists, given the medalist is from the United States. So the athletes who are from the United States are right here. So we're talking about the 121 athletes who are from the United States. So the probability of choosing someone from the United States is in the denominator. Or another way to think about it is you can just say how many people there are from the United States in this situation. So 121. And then in the numerator here, it's the probability of someone winning a bronze and they are from the United States. So how many people won a bronze and they are from the United States? It's 38. So it's 38 over 121. That's equal to 0.314. B, given that the chosen medal is not a gold medal, so how can we represent that? Well, we're going to be finding a probability here. Given that the chosen medal is not a gold medal, so not a gold medal is the complement of a gold medal. So let's think about what medals are not gold medals. So as we look up here, we're talking about the silver and bronze medals. Those are the ones that are not gold medals. So we're focusing our attention there. So given that the chosen medal is not a gold medal, what's the probability that it came from the United States? So given that it is not a gold medal, what's the probability that it's from the United States? Or you might say, what's the probability that athlete chosen randomly is from the United States if the athlete did not win a gold medal? So the denominator is going to be those who did not win a gold medal. Well, how many athletes total did not win a gold medal? It is 55 that won silver and 64 that won bronze. That's 55 plus 64. That's those who did not win a gold. And then the United States athletes who were in that group, that's going to be our numerator. The United States athletes, there were 37 that won silver from the United States and 38 that won bronze. 37, we're done red. 37 plus 38. This is equal to 75 over 119, and that is equal to 0.630. So there you go. The probability that an athlete is from the United States, given they did not win a gold medal, is 0.630. You should be able to put that in a sentence, and that's the sentence that I just said right there. Okay. Next problem. According to a recent report, Pandora and Spotify are the most used music streaming apps. A group of AP Stats students surveyed all the seniors in the school and found that 68% use Pandora. So the probability of a student using Pandora is equal to 68%. You can write 68% or 0.68, either one's fine. 38% use Spotify. So the probability that someone uses Spotify, that is equal to 38%. and 24% use both. So that'd be the probability of Pandora and Spotify. That's equal to 24%. Suppose we select a senior at random. Given that the person uses Pandora, so we're going to be finding the probability of, we know that it is given that the person uses Pandora, so that's going to go on the right side there. What's the probability that she or he uses Spotify? Okay, uses Spotify. So this is going to be the probability of using Pandora in our denominator. And then the numerator is going to be the probability of using Spotify and Pandora. Well, we got what we need over here on the left side. So the probability of someone using Spotify, given that they use Pandora, is equal to the intersection of Spotify and Pandora, which is right here. That is 24%, over the probability of someone using Pandora. That's right there, 68%. And this is equal to 0.353. There you go. So that's the probability of someone using Spotify given that they use Pandora. You could put that in a sentence. The probability that this would be a senior at the high school. All the seniors were surveyed. So given that, let me back up. Given that a senior at the school listens to music on Pandora, there is a 0.35 probability that they also listen to Spotify. There you go. That's your sentence. Let's talk for a moment about independent events. A and B are independent events. Well, some examples of independent events that you know about already: flipping a coin more than once. These are independent events. Rolling a die. Knowing what happened in the past has no impact on what happens in the future. So that's pretty much the definition in simplified terms. A and B are independent events. If knowing whether or not one event has occurred does not change the probability that the other event will happen. In other words, events A and B are independent if, and we'll talk about this in a second. But if you flip a coin and you get heads, you pick up the coin to flip it again. The probability of flipping heads is the same thing. So whether or not one event has occurred does not change the probability that the other event will happen. One roll of a die has no impact on the next roll of a die. So this, we'll take a look at an example of this in a second, but the probability of event A given event B happens is equal to the probability of event A given the complement of event B happens is equal to the probability of event A. And then alternatively, you can see it's the same thing just with A and B swap. So let's look at a situation where the events are not independent first. I'm not going to dive into the details of this too much, but notice we have a two-way table, genders across the top, male and female, pierced ear vertically. We've got 84 out of the 88 females have a pierced ear. 19 of the males out of 90 have a pierced ear. So if the chosen student is a male, we can find the probability of them having a pierced ear. So the probability of a pierced ear, given that it is a male, there's 19 males with a pierced ear out of 90. That's a probability of 0.211. So now we're going to take the complement of the given. So the probability of a pierced ear, given that it is not a male, that would be a female here. So the probability of a pierced ear, given that it's a female, well, there's 84 females with a pierced ear out of 88. That's 0.955, very high probability. So knowing that the chosen student is a male changes and greatly reduces the probability that the student has a pierced ear. So if I tell you the student is a male, you know there is a much smaller probability that the student has a pierced ear as compared to if I told you the student was female. So these are not independent events, not independent events. If these two were equal to each other, then they would be independent events. So let's take a look at an example now where the events are independent. Is there a relationship between gender and subject preference, math or English? The two-way table summarizes the relationship between gender and student preference for a class of 25 stat students. We got male and female across the top, math and English vertically here. Suppose we choose one of the students in the sample at random. Are the events male and math independent? Justify your answer. So if the probability of a student preferring math, given that they are male, well, we have 10 males. That's going to be our denominator, right? We're looking right here in that column. 8 of the males prefer math, so 8 out of 10, that's 0.8. Let's compare that to the probability of a student enjoying math. If they are not a male, the complement of male, that'd be female. And if these two are equal to each other, then the events are independent. So now we're going to look at the female column here. We got a total of 15 females. 12 of them prefer math over English. That is also 0.8. So the probability of a student preferring math, if they are male, is equal to the probability of a student preferring math. And you could say female. I'm going to say complement of a male. Those are equal to each other. Therefore, the two events are independent. These are independent events. Okay, great. All right, thanks for watching. Good luck on your homework.